Do you remember? So I can try to pick a problem. Oh, we didn't have a quiz. No wonder I don't remember. Thank you for letting me know. That's very good that you remember this. So last time we started to talk about section 7.3, and my goal was to show the analogy with a previous section with 7.4. So now we're kind of going backwards and looking at various little exercises that could be related to the real life situation. So maybe I'll check out problem number 15 that could be connected to some students that says smoking and college education. How about that? So we can see what is going on in terms of smoking in the campuses. So they're talking about 785 subjects completed 4 years of college, and from them 144 smoked and 641 didn't smoke. Okay, so let's start to write this down in exercise number 15. So I'm in the section 7.3. We have a sample sized 785, and out of 785 we had number of smokers that was 144, and the rest not smoking students. So then we need to use a significance level to test the claim that the rate of smoking of college is less than 27% rate, which actually corresponds to the rate of smoking in the general population. In other words, that proportion of college graduates that smoke is less than 27%, which is a rate for general population smokers. So this is claim. I already know it has to be either H1 or H0. So I have to put this in H index 1 because there is no equal sign, right? H0, its opposite will be a statement with proportion greater than or equal, right? The opposite will have equal. So no wonder we put P is less than 0.27 in our claim. So now I need to test this with a favorite hypothesis setting. So I put H1 on the left side because it corresponds to the smaller. So it's smaller, it's on the left. And H0, the rest of the region. So that'd be everything else. Another piece of data here is 0.01 significance level. So 0.01 will correspond to the area of this H1 region. So I need to know the critical, the border value Z score for that. And it looks like 0.01 will be giving me some negative value. So I need to find the closest number in these tables to this particular area. So 0.01, I can see it somewhere here. And I notice that if I go up to the row above, I see this here, 0.01. And it's closer to 0.099, because if I look at 100, which is surrounded by 99.0099 and 102. Then to get to 102, from 100, I need to go farther, right? Kind of twice farther to, let me put this correctly, 0, 1, 0, 2. So that'd be farther than from 0, 1, 1, 2. I need to wake up. So I guess we just be careful when 0, 1, 2, not 1, 2. Which is going to be twice farther away from my values. So I go to the closer one because I'm sitting right in that position, right? 100 is in between of 99 and 102, but since 99 is closer, it will give me my Z score that we are looking for. And this is negative 2.3 composed with 0.3. So we got negative 2.33. So now I'm going to utilize the data from the sample that they considered, and that will give us Z-score, which is coming out from this particular formula that we saw in that section. So I need to have P and I need to have Q. So I already know that from hypothesis, I can pull out value of P, which is 0.97. That's what they're comparing with. Even though they say maybe it's less, but we always get our population information with from the hypothesis. So now I need to know the Q, the complement of P. So the complement Q will be simply 1 minus P. And if 27% is for smokers, then the complement of this, which is 73%, right? 73% and 27 compose 100%. So that will be for non-smokers. So now I'm going to utilize the information from the sample, which we call as a P with a hat. So this is going to be 144 out of the total 785. So we have everything we need to put the numbers in that formula. So for P hat, for sample proportion of smokers is 144 divided by 785. Then we have to subtract P, the population proportion, or 0.27 from this. And then to divide by a square root from this same 0.27 times Q, the complement, or 0.73, and we put this over the total of 785. This is what I need to enter in my calculator. And I need to also use parentheses here. Now you say, what about parentheses here inside the square root? You can put the parentheses anywhere you like. It's not gonna change anything. You don't have to, but I can do this. I can put parentheses inside the square root. Makes no difference. So let's enter this, and I hope that you are also entering these numbers in your calculator simultaneously. 789, then you need to move farther here, and then to subtract 0.72 from this in the parentheses, and then divide this whole thing by the square root. So if you wish parentheses, you can put it there, but it doesn't make difference. Again, you can try to put parentheses if you want to. So I put 789. Thank you for checking this out. It's 785, very timely change. It's very nice when you tell me that right away, as I know that sometimes people just sit and wait until I get the whole answer, and then they say, Alex, you remember that you put some wrong number and I have to redo the whole thing. So that's great that you told me right away. So please don't hesitate. If something is not entered correctly, let me know. So please notice my z-score is way out of range, right? So it's minus 33 point something like 86 ... So this out of range z-score is going to be deeply, very deeply here, right? Minus 33 something. So this is in H1, definitely, right? Because that's area of H1. So this tells me the answer to this question. I say yes to H1 because I got in that region. And the opposite statement, the A0, I deny, say no to it. And if you return back 27, oh, I put 72. Oh, okay, so looks like I did, 0.72. That's why I got so far away, right? So this is really not that, it's 27. See, when you switch these little digits, it's called dyslexia. So I guess I need to check myself at the doctors, because if I start switching digits, that's dyslexia. That's definitely no good. So -5. Well, I guess I got lucky because -5 and 4, 6 something is also the number that's still in the region, right? But yeah, I shouldn't really misenter data, so that's no good. So -5.46 ... So still in H1, still say yes to H1, so we still support the claim. So what was the claim? Well, the claim says that college graduates have tendency to smoke less than general population, smoke lower. And why would college graduates smoke lower rate than the others? Is that because they make less pay, or, well, I'm just kidding, who knows, right? That's another question to our, I guess, statistics subject. It's a question to those people that know a little bit more about people's tendency to smoke. But it looks like we have a very interesting observation, and we had a proof that indeed college graduates smoke less. It's interesting. Any claim can be tested. This claim had nothing to do with the average, with mean. This claim had to do with percent of people that smoke or do not smoke. So for this type of story, it makes no sense to mention the average, because it's just the proportion of smokers to non-smokers. I guess this is a great thing that we have here in this textbook, because we can see the applications of statistics. And as I said, you can create your own test on just about any population that you're working with. And of course, the key question might be, if you ask Alex, how do I know what's the population average is? What is the mean for the population? How can I possibly know it if I don't really have any information about this? And turns out the chapter 6 is actually telling you how you can get information about the populations that you have absolutely no idea about. So turns out that in this particular section, we're going to estimate our population's means. So what I want to do is get the formula here. That's what I'm looking for right now. And this is, I guess, the key part of this section. So I'm trying to go to section 6.3. I'm finally here. And turns out that in section 6.3, there is a formula that actually gives me that estimate. Okay, if you need to go, of course you can go, and we need you to stay healthy. That's very, very important. So anyways, if you remember the story about the big population that you probably cannot study entirely because it's just too big, but what you can do is pull out a part of this population, which is called a sample. And that sample that you can say a size little n, you can put your hands on because you can calculate its mean, you can calculate just about anything about the sample, right? So I can find, let's say, mean and then standard deviation. That's what we did already. And then based on this information, I can say what population mean is. We call it with letter mu, just to make sure that it's not the same because that's related to population, and also the standard deviation, which is sigma. So based on the calculations that come out from our sample, we can get the results about entire population. How about that? And for that matter, we use the old favorite formula for the z-score, which is x minus mean divided by standard deviation. And then we multiply by standard deviation both sides of this little formula. So it'll be z multiplied by sigma, and here standard deviation disappear. And then you can also bring your mean over to the other side. So it'll be like a positive mean, and that sigma and z you bring over to the other side. But since the formula was dealing with a standard deviation over square root of n, there'd be also over square root of n here and there. So that's where we get that estimate. So in general, they write the following formula for the estimate. So they say if you have some level of confidence and you want to be, well, pretty confident that you did it correctly, because if you are not confident what you did, that's pointless, right? So if your level of confidence is about 90 or 95%, so let's say 95%, that's standard level of confidence that we want to keep, then the z-score that cuts out is 95%. And of course, on the other side will be a positive z-score. So I can say one of them was a minus, right, which is on the left side of 0. The other was a right side. We'll be cutting out the region with area of remaining 5%, right? Because total is 100. So if 95% is already here, then 5% divided by 2, or 0.025, which is 2.5%, since these two regions are equal because the picture is symmetric, then each of this tail will be 2.5%. The key idea is because we have word distribution here, and distributions, they have entire 100% description for our population. So I can find the actual z-square here that corresponds to this particular level of confidence. I just need to look at the tables and locate that 0.025 area in it. And I think I can find exactly this number somewhere here, right? 0.025 with another 0 will give us the actual negative 1.96. So that'd be a minus 196 for z-square, which is on the left side. And then on the right side, since it's the same but positive, it's going to be positive 196. So based on this idea, we say that our population mean should be somewhere on this confidence interval with a chance of 95% to be there. And since my formula there was a x bar minus z sigma, so I say x bar with minus z, so that negative z-square, and then standard deviation over square root of n, or the other side of this estimate will correspond to the x bar plus, because now we have a positive z-square, the cutoff level for the other side. And our population mean has to be somewhere on the interval in between of these two regions. So here's so-called confidence interval. So there is a left side and there is a right side. So the confidence interval for the estimation for the population mean. So in this chapter, we'll be able to estimate anything about our population just based on the information that you pull out from the sample. So all you need is to get sample mean, and based on that sample mean, you will be able to find population mean. But it's not going to be exactly the number. It's going to be the interval with some chance of probability. I say, well, who needs this kind of estimate? Well, let me do the problem and you will see that it's actually very, very useful. So let me find some exercise in this section so we can, based on its example, to see how this whole process is being utilized. So where are the exercises? Somewhere here. So let's try one of these exercises here. So for example, how about problem number 11? So that says, times between the uses of a remote control by males during commercials is what we need to find with 90% confidence. So in other words, let's say some advertisement company wants to post their commercial and definitely pay for it and for some TV program, and they want to be sure that their commercial is visible. So what they did, they studied that for a sample of 25 males, the average time they switch channels when commercial starts is about 5 and something of seconds. And of course, they also notice there is a standard deviation here, which is 2.5. So standard deviation 2.5. So some do it faster, some a little slower, but the average is some like 5. So they want to be 90% confident that they know the actual average for entire population. So of course, who knows the what's going on with entire population of males, but they consider 25 of them, and now they're going to make an estimate about the entire population. How about that? And they want to be 90% confident. In other words, they want to know the z-scores, and where one will be with a minus sign, which is on the left, and the other is on the right side with a plus, so that their commercial is visible. So they will probably make shorter commercial or put the main information or some sizzle in the very beginning, so people before switching channel all of a sudden got interested and don't switch channel, start to watch their commercial. So that, I guess that's the main idea, because otherwise why to spend the money for a very long commercial that nobody's going to watch anyways. So looks like now my level of confidence is 90. It's a little bit lower, which is usually okay for the cases that not related to the life or death. And I want to show you where you can actually get this z-score right away without breaking this confidence and so forth to both sides. You can look at the table at the end of this little chart with z-scores, and notice that for confidence level of 90%, z-score is 1.645. So this is going to be negative 1.645, and on the other side will be a positive 1.645. You see this chart actually brought you with the z-score. So if you had 90% confidence, so here will be a 0.05, 5%, and on the other side, another tail is another 0.5, right? Because you add them, you get 10, and add with 90 is 100 exactly. Then from this chart, you can see the confidence level gives you 1.645 critical value. Just like in my previous example, for 95% confidence level that we had in the previous example, it was 1.96, and that's exactly what I had found from the tables. So technically, you could have just looked at the tail of 0.05. Let me show you that. So if you locate 0.05, or actually the number closest to it in these tables, and it'd be right in between 0.505 and 0.495, then you're going to need the number exactly in between. It's like 500, which is exactly in between 505 and 495. Since you don't have the closest, you need to follow this arrow, and you take 1.645, and that's exactly what they gave it to us, because you actually need to average 0.4 and 0.5, which is going to give you 0.45, that total to 1.6, and that will give you 1.645. So looks like the chart on the bottom of the page is definitely convenient to use, but you don't have to use it. It is really up to you. So going back to this same story, looks like we're gonna need to get the confidence interval, and the confidence interval is what we have here. So if you observe this formula, you may notice that one side is same as the other side, but one has a minus sign, and the other has same numbers but with a plus sign. So what I'm going to do is put X bar here, which is 524, and then I'm going to subtract from it that z-score, which is 1.645, and then I times this by the fraction, that has a standard deviation 2.5 on the top, and the square root from this 25 sample size, right? 25 on the bottom. Then that'd be my left end of calculation. And for the right end, I'm going to do exact same thing, but I need to put a plus instead of minus. So let me place this in the formula and see what this comes out to. So 5.24 minus z, which is 1.645 times by 2.5, and then divide this by square root of 25. Or if you want to just put 5, that's the same thing. So notice that I got the answer. I hope I enter it right at this time. So my left end is 4.4175 to estimate that interval. So for the other side, all I need is just to change the minus here with a plus. And I don't have to re-enter the whole thing. I can just highlight that, enter with a minus, delete the minus, and enter plus. And the calculator will give me the answer right away. How about that? It's a 6.0625. So my population mean, we don't know what it is, but it is somewhere on this interval. Let's say from 4.4 seconds to 6.1 approximately seconds. So we have no idea where the population mean is, but we know with 90% confidence that it is somewhere on this interval. So what should they do? Well, I guess they should go with the worst case scenario. What if it is 4.4? See, we always try to go with the lowest, with the best case scenario. And in this case, it's going to be the lowest time. So they want to make sure that they shoot such an advertisement that first 4.4 seconds, the person who watches TV is not going to change the channel for whatever reason. That's, I guess, their commercial idea, how to keep person interested. But I guess if they succeed in this, well, then their commercial will be successful. So people actually gonna get information from it, because otherwise it may not be even a good idea to waste the money, because nobody's gonna watch it. So they just switch the channel and that's about it. So I think that's a very, very useful marketing idea, isn't it? And you can get it just by doing your own calculation. That's the power of it. You just select a sample of 25 people, find the average, find standard deviation, and with whatever level of confidence you want, you can get the answer for the length of commercial. Isn't that powerful? That's very useful, isn't it? So I guess this is an exciting part of statistics that you can actually yeah, some people say the more you know, the more you get confused, right? But yeah, well, I'm just kidding. But anyways, to be honest, this is one of another nice applications besides testing whatever claims like we did in the chapter number 7. Now I return back to chapter 6, and looks like it's another exciting part of the story. So I hope you will like to do these exercises over weekend. In fact, we have a long weekend, right, for this particular time, because it's a Veterans Day holiday. Tomorrow, the college is closed completely, no classes at all. I say we got unlucky, that's Tuesday, Thursday class. Well, I can let you go in the spirit of coming holiday without a quiz. I think that's the best I can do for you today. So I can let you go without a quiz, and I hope I got you excited so you can celebrate the Veterans Day if you know how to celebrate it. If not, you can just relax and recharge for the next week. So have a good long weekend, and thank you for coming. No quiz today. I guess in the spirit of coming holiday, you just enjoy the long weekend.